This $90 steel tank can store your solar energy for 30 years with zero degradation. No lithium, no cobalt, and full capacity decade after decade. A durability no battery on Earth can match. Yet despite this physics being proven for over 250 years, we are told storage means $15,000 in batteries that lose capacity every single year. It is called compressed air energy storage. By the end, you will know what it is, how it works, and how to build your own. Let's dive in. Right now, if you want to store the solar energy your panels make during the day, you have one option. Bolt a lithium battery to your garage wall and write a check for over $15,000. So let's look at what that battery is actually doing to your wallet and why it starts failing the moment you plug it in. The most popular home battery in America is the Tesla Powerwall 3. It stores 13.5 kilowatt hours of energy. It costs between $15,300 and $16,200 installed. And Tesla guarantees that after 10 years, it will retain just 70% of its original capacity. That is not a failure. That is the warranty promise. 70% is the floor Tesla is comfortable putting in writing. Independent testing from the ITP Renewables Battery Test Center in Canberra, Australia, tracked real-world degradation across thousands of Powerwall 2 units. They found a capacity loss of 21% after roughly 2,500 cycles. At one cycle per day, that is about 6 years and 9 months of use. And there is a detail most buyers never hear about. The Powerwall 3 warranty requires a continuous internet connection to your home Wi-Fi. If your unit loses that connection for an extended period, Tesla reduces your warranty from 10 years down to 4. You are spending $15,000 on a storage device that needs ongoing permission from a server in Palo Alto to honor its own guarantee. Now consider the replacement math. When that battery hits the 10-year mark and sits at 70% capacity, you are not getting a refund. You are buying another one, another $15,000. Your solar panels are warranted for 25 to 30 years. Over that lifespan, you are looking at 2 to 3 battery replacements. That is $45,000 to $60,000 in storage alone, just to use the energy your own panels produce. Every single one of those discarded battery packs ends up classified as hazardous waste. Lithium-ion cells cannot go in your regular trash. The lithium itself is strip-mined from open pits in the Atacama Desert in Chile and hard rock operations in Western Australia. It is refined through a chemical process that consumes roughly 500,000 gallons of water per ton of lithium extracted. The refined material is shipped across the Pacific to battery factories in China and South Korea. There, it is assembled into cells, packaged, and shipped again to the United States. It gets installed in your garage, and in 10 years, you throw it all away, and the entire cycle starts over. And when you hear what the alternative costs, and how long it actually lasts, you will understand why nobody in the battery industry wants this conversation happening. The average American household uses about 30 kilowatt hours of electricity per day. A single Powerwall stores 13.5. That means if you want full off-grid capability, you need at least 2 units. That is over $30,000 before installation, and both of those units will be at 70% or below within a decade. Meanwhile, the global lithium-ion battery waste stream is projected to exceed 8 million metric tons per year by 2035. Right now, fewer than 5% of lithium-ion batteries in the United States are recycled. The rest go to landfill or sit in hazardous waste storage. That is, the system we are told is the only path to energy independence. But there is a storage method that uses nothing but air and a steel tank. No chemistry, no rare earth metals, no degradation curve. And the physics behind it have been understood since 1662. The core principle is called Boyle's Law, named after the Anglo-Irish natural philosopher Robert Boyle, who described it over 360 years ago. It is one of the most fundamental laws in physics. When you decrease the volume of a gas while keeping the temperature constant, the pressure increases proportionally. Squeeze air into half its original space, the pressure doubles. Squeeze it to 1/10, the pressure rises tenfold. That pressure is stored energy. It does not decay, it does not degrade. It does not need a firmware update or a Wi-Fi signal. The air holds its charge until you release it. In a compressed air energy storage system, Your solar panels power a standard electric compressor during the day. The compressor pushes atmospheric air into a pressure vessel. In this case, that vessel is a repurposed propane tank, rated by the American Society of Mechanical Engineers for sustained high-pressure service. When the sun sets and you need electricity, you open a valve and release that pressurized air through a small air motor connected to a generator. The air expands, spins the motor turns the generator, and the generator produces electricity. That is the complete system: a compressor, a tank, an air motor, and a generator. 4 components: no lithium chemistry, no thermal runaway risk, no cell balancing software, no fire suppression requirement. There's a second principle at work that makes this even more practical at household scale. It is called the ideal gas law. When air is compressed, the molecules pack tighter and the temperature rises. That heat is not wasted energy if you design for it. A simple heat exchanger, nothing more than a coil of copper tubing submerged in a water tank, routes the compression heat directly into your domestic hot water supply. When you later expand the air to make electricity, the air cools. That cold output can be ducted into your living space or routed to your refrigerator intake. This combined approach is called polygeneration. You produce heat, cooling, and electricity from a single compression cycle. Researchers at the University of Florence in Italy tested exactly this configuration. They stored air at 225 bar in a vessel of just 0.25 cubic meters, roughly 66 gallons. That single vessel captured 96% of the excess solar energy from a residential rooftop array, and the tank was no larger than a standard water heater. Now, if you are thinking this sounds too good, a team at the AGH University of Science and Technology in Krakow, Poland, built a working micro CAES prototype. They published their results in Applied Energy in 2023. They measured a round-trip electrical efficiency of 65%, using a reciprocating piston expander with pulse width modulation control. The system produced 1.1 kilowatts of continuous power. That is enough to simultaneously run a refrigerator, household lighting, a phone charger, and a Wi-Fi router. And every researcher who has tested these systems arrives at the same conclusion. The storage vessel shows zero capacity loss over time. A steel tank does not have a cycle limit. It does not have a calendar life. It does not degrade from temperature swings or chemical reactions. It holds air, and air does not expire. But the lab results are only part of the picture. The proof that compressed air can power entire communities for generations has been hiding in plain sight, and it goes back further than most people realize. In 1857, engineers began construction on the Fréjus rail tunnel beneath Mont-Cenis in the French Alps. It was one of the most ambitious civil engineering projects of the 19th century. The drilling teams from both France and Italy used pneumatic rock drills powered by compressed air. Those drills replaced manual labor and increased drilling speed from 60 centimeters per day to 2 meters per day. The tunnel took 13 years to complete and stretched 8 miles through solid alpine granite. It proved, on a scale no one could deny, that compressed air could deliver sustained, reliable industrial power in the most extreme conditions imaginable. Within 3 decades, Victor Popp took that same principle and applied it to an entire city. In 1978, engineers at Eon Kraftwerk commissioned the world's first commercial-scale compressed air energy storage plant in Huntorf in Lower Saxony, Germany. The system stored air in 2 underground salt caverns totaling 310,000 cubic meters at pressures between 43 and 70 bar. Output was 290 megawatts of electrical power. That plant is still running today, 47 years of continuous operation. In 2007, it was upgraded to 320 megawatts, and the original mechanical clutches from 1978 have never been replaced. In 1991, a second plant went online in McIntosh, Alabama. Built by the Alabama Electric Cooperative for $65 million, the McIntosh facility stores air in a 19 million cubic foot salt cavern. It delivers 110 megawatts for up to 26 hours per discharge cycle. That is 2,860 megawatt hours of storage. The cost per kilowatt hour of capacity works out to roughly $23. Compare that to the Powerwall 3 at approximately $1,180 per kilowatt hour installed. That is a cost difference of over 50 to 1. And the McIntosh Salt Cavern has a projected operational life exceeding 100 years. But you do not need a salt cavern or a utility budget. The Amish proved that decades ago. Communities across Lancaster County in Pennsylvania, Holmes County in Ohio, and LaGrange County in Indiana have been running entire workshops on compressed air. They power farms and parts of their homes using pressurized air stored in large propane tanks. They use diesel or gas-powered compressors to fill ASME-rated vessels, then distribute the air through steel pipes. That air powers table saws, drill presses, sanders, lathes, and pneumatic submersible water pumps, pulling from wells over 150 feet deep. In 1997, Jonas Zook started Keystone Air Power out of his basement workshop in Lebanon County, Pennsylvania. By 2024, that business had grown into a 52,000 square foot hardware store and tool supply. The entire facility was fully off-grid, built around a cutting-edge pneumatic system with no connection to the electrical grid whatsoever. The Amish discovered what the battery industry would prefer you never consider. You do not need to convert energy into chemistry and back again. You can store it as pressure. And pressure does not degrade, does not require replacement, and does not end up in a landfill. If you want to power, heat, and cool your home off-grid, the Passive House files show you how. Full plans, exact materials, and the honest numbers nobody else gives you. It's not too late to start lowering your bill. Scan the QR code and see for yourself. And the Amish were far from the first to prove the concept at scale. In 1879, Austrian engineer Victor Popp founded the Compagnie Parisienne de l'Air Comprimé in Paris. Starting with a network of pneumatic clocks synchronized by air pulses through underground pipes, Popp's company quickly expanded. It began powering elevators, industrial lathes, sewing machines, and commercial beer pumps across the entire city. By 1960, the company was serving nearly 10,000 clients through a distribution network running beneath the streets of Paris. The system operated continuously for 115 years, from 1879 until 1994. Paris did not shut down compressed air because it stopped working. The network closed because local industry declined, and maintaining aging underground pipes was no longer economical. The technology itself never failed. And yet almost nobody in the American energy storage conversation has ever heard Victor Popp's name. Proven at utility scale since 1978. Proven at community scale by the Amish for decades. Proven at city scale in Paris for 115 years. So, why can you not walk into a hardware store and buy a residential compressed air storage unit? The barrier is not performance, it is paperwork. Every financial incentive in the American energy storage market was designed around lithium-ion chemistry. The Inflation Reduction Act of 2022 created a 30% residential clean energy tax credit for standalone battery storage of 3 kilowatt-hours or larger. On paper, a compressed air system qualifies. The IRS defines eligible storage technology as any system that receives, stores, and delivers energy for conversion to electricity. A CAES system does exactly that. But in practice, the credit is unreachable. No manufacturer has obtained a UL listing for a residential micro CAES product. No installer network exists to certify the installation. No permitting pathway has been established in any major municipality. Without a certified product and a licensed installer, no tax professional will put it on your return, and no home appraiser will recognize it as an improvement. A homeowner who installs a Powerwall gets a 30% federal credit, a turnkey installation, and a product listed in the Fannie Mae appraisal guidelines. He also gets an insurance rider that covers the system. A homeowner who builds a $500 CAES setup from a propane tank gets none of that. No credit, no appraisal value, no utility rebate, no coverage. The Department of Energy has published CAES research for decades. Sandia National Laboratories tested it. The New York State Energy Research and Development Authority funded a full feasibility study on mini CAES using manifolded high-pressure vessels for community deployment. But none of that research has resulted in a consumer product, a retail listing, or a code pathway a homeowner can follow. The system was never designed to ban compressed air. It was designed around batteries, and anything outside that design is invisible. In a market where tax credits and installer certifications determine what gets built, invisible is functionally the same as prohibited. The American home energy market does not reward the best technology. It rewards the technology that fits inside the existing paperwork. And right now, that paperwork has exactly one shape: lithium. Here is how you build one anyway. The storage vessel is a standard ASME certified propane tank. ASME tanks are built from thicker steel with stronger welds than DOT portable cylinders. The critical advantage is that ASME tanks require no recertification. A DOT cylinder must be requalified every 12 years. An ASME tank is certified once at the factory and remains certified for the life of the vessel, which routinely exceeds 30 years with zero structural maintenance. A new 120-gallon ASME vertical tank from Flame King or Manchester Tank runs between $400 and $600 retail. A used or decommissioned tank from a propane company retiring older inventory sells for $50 to $120. These vessels are rated for pressures well above residential CAES requirements. They were engineered to contain liquefied propane at 250 pounds per square inch in direct sunlight. Holding compressed air at 150 pounds per square inch is well within their design margin. For the compressor, choose an oil-free electric model rated for at least 150 pounds per square inch continuous duty. California Air Tools and Makita make reliable units for $200 to $400. Oil-free is not optional. The air going into long-term storage must be clean and dry. Add an inline moisture separator and desiccant filter for $20 to $40. Moisture promotes internal corrosion over decades. Eliminated at the inlet, and the storage side requires zero maintenance. The air motor is what converts stored pressure back into rotational energy. Gast Manufacturing and Parker Hannifin both produce vane-type air motors for industrial use at between $150 and $300. Connect the motor to a permanent magnet DC generator or a small automotive alternator. The output charges a small 12-volt deep cycle buffer battery, costing $60 to $80. This buffer battery is not your storage, the tank is. The battery smooths output during the pressure drop at the end of a discharge cycle and provides a stable voltage reference for your inverter. Total system cost for a functional residential micro CAES setup runs between $500 and $1,200. That is 3 to 5% of a single Powerwall installation, and the propane tank will still be holding pressure at full capacity when the third replacement Powerwall is on its way to a hazardous waste facility. You can build this in a weekend with basic tools. No electrician license, no specialized training, just a wrench, a pipe cutter, some thread tape, and a basic understanding of how pressure systems work. One critical safety rule: never use PVC or plastic pipe for compressed air delivery. PVC becomes brittle under pressure cycling and can shatter without warning, sending fragments at lethal velocity. Use black iron pipe, copper tubing, or aluminum pipe rated for compressed air service, and install a pressure relief valve on the tank, set to open at 10% below the vessel's rated maximum. These valves cost $8 to $15. And they are the most important safety component in the entire system. If you are designing above 200 psi, consult a licensed mechanical engineer for pipe sizing and relief valve specification. Here are the honest limitations. Round-trip electrical efficiency for a basic home setup runs between 30 and 65%. Lithium batteries achieve roughly 90%. On a per-cycle basis, lithium is more efficient. But efficiency per cycle is not the same as lifetime value. A system that runs at 50% efficiency for 30 years produces far more total energy than one running at 90% for 10 years, because the second system ends up in a landfill and the first one keeps running. The second limitation is mechanical complexity. Compressed air requires a motor and generator to convert back to electricity. That is more moving parts than a battery. But those parts are rebuildable with standard hand tools. A dead lithium cell is not. The third limitation is noise. Compressors produce sound. If your property line is close to a neighbor's window, plan for sound insulation around the compressor enclosure, or schedule compression during daytime hours when ambient noise is higher. The compressed air energy storage system is a 250-year-old answer to a 21st century problem. It stores energy as pressure inside a steel vessel that costs less than a single monthly electric bill and lasts longer than most home mortgages. A lot of what this channel covers sits outside the conventional norm, not because it stopped working, but because the financial system